Hi, good evening everyone. Welcome to Unacademy YouTube classes. So welcome everyone. Hi. Are you getting now? Are you getting? Yes. Are you audible? Yes. So good evening everyone. So welcome to Unacademy Plus YouTube classes. See for the plus classes for details everything you can see the below description. You will get all details and our regular special classes also going on. Daily evening 6 to 7 you can join in that classes in our plus classes. So watch and utilize this. Okay. So we will continue electrostatics. So in electrostatics means in electric charges and fields. In last class what I was explained electric field. Electric field is what? The space surrounded by a charge up to which its influence can be act. So that is electric field. So that electric field we can represent by what? Imaginary lines. They are called electric lines of force. If field lines are parallel to each other, having same space between them, that is called uniform electric field. And current means what? Non-uniform electric field. Okay now. Electric field is what? See, positive means away and negative means towards. Na? So electric field lines are here what? From positive charge away and from negative charge towards. They can move. Okay. So here already Hi Tarun, good evening. Good evening Tarun. How are you? Yes. See, electric field due to point charge over C. Let us consider a charge Q placed at some point O. From this charge at a point P having a distance R from the charge. Okay. we have to find the electric field. So that we have to place what, a test charge here. So test charge means a small point charge. There is no effect of this. So due to this, what, see, force will act between them. 1 by 4 pi epsilon naught q naught by r square. Now what is the electric field on this charge on this at this point P? What is the electric field due to this charge? Due to this charge means the force due to this charge act on here. That means F by q naught. So 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught q naught by r square by q naught. So electric field due to a point charge is what? 1 by 4 pi epsilon naught q by r square. Q by r square. And in vector form we can write what? E bar equal to 1 by 4 pi epsilon naught q by r square into r cap, or 1 by 4 pi epsilon naught into q by r cube into r bar. This is field due to a point charge. Suppose here a charged particle is moving under equilibrium in an electric field. A charged particle is what? Is under equilibrium in electric field of intensity E bar directed downwards. Directed what? Downwards. Electric field intensity. Charged particle is what? It is in a uniform electric field which is acting what? Downwards. It is in equilibrium. So it is in equilibrium means what? Net force will be equal to what? Balances to the weight of the particle. What is the net force here? See, E equal to, we have F by Q, right? So F equal to QE. So that QE equal to mg. We can write QE equal to mg. Okay now? Okay? QE equal to mg. Suppose here, if the charge particle, we can take number of electrons in a conductor, then we can take Q means N into E. Into E equal to mg. So N value is mg by E into E. Or see, in a uniform, it is moving with acceleration A, for example. Okay, means in case of what? Motion of a charged particle in uniform electric field in which force of gravity is 0. Means gravitation force is does not acting. G we are taking 0. Gravitation force is not acting. Then in that case what? F equal to ma, which is equal to what? QE. So in that case A equal to what? QE by m. Acceleration of the particle A equal to what? QE by m. Okay now? Acceleration is QE by m. Just 1 minute. Light is not there. I on the Sai Manikanta. Hi Sai Manikanta. Hi. Are you getting now? Now? Are you getting video clearly? Yes. So A equal to QE by M. Okay now. Now acceleration means without a gravitational field. Suppose see the particle is what started in the uniform electric field from rest. From rest means U equal to 0. So after some time t, okay, at a time t, it travel a displacement s with acceleration a uniform acceleration. Then what about its final velocity is v? Then we have what? From v equal to u plus at. U is what? 0. A into t. What is a here? QE by m into t. This is the velocity. So what about its kinetic energy? Kinetic energy is of m v square. So of m into what is v square? Q square e square t square by m square. M get cancelled. So q square e square t square by 2m. Kinetic energy. Okay now? This is the kinetic energy. Now this kinetic energy is what? Nothing but work done on the particle. So what is the work done? Actually change in kinetic energy. Final minus initial. Initial velocity is 0 now. So W equal to half mv square, which is equal to what? Q square e square t square by 2m. This is the work done. Okay. Or general formula also you can apply. Work done is what? Force into displacement. What is the displacement of the particle here? See, displacement is what? From S equal to ut plus half at square. U0 na? Half into QE by m into t square. So displacement is QE t square by 2m. So work will be what? Now force into displacement means in another formula. Force is what? QE into what is the displacement? QE t square by 2m. Again it is what? Q square e square t square by 2m. So work done it is what? Nothing but kinetic energy. See? Okay. So like this we can derive. And we can apply same for what? Projectile motion also. Horizontal projectile, oblique projectile. In that case, instead of acceleration, we can take QE by m. Okay. Money. Okay now? Now, see, we can apply for what? Projectile motion. In projectile motion, we have what? Maximum height, range, time of flight. In that case, what? Maximum height is what? U square sine square theta by 2g. And range U square sine 2 theta by g. And the time of flight 2u sine theta by g. Instead of g, we can apply a what acceleration due to this electric field also. That means instead of g we can substitute g plus r minus r plus a. What is a here? QE by m. Now maximum height u square sine square theta by 2g. That is 2 into g minus r plus QE by m. Range u square sine 2 theta by g. In time of flight 2u sine theta by g. Okay. But where we can use minus and where we can use plus here. See, if electric field is in upward direction, electric field is acting upward, now you can take minus. And if it is acting downwards, now you can take plus. Yes. Are you there, guys? Are you following? Yeah. So electric field is upward. Upward means minus. If it is acting downward means plus. So very important applications these are. For positively charged particles it is. Suppose see a simple pendulum. Simple pendulum, you know na? Bob. So generally time period is what? T equal to 2 pi root of L by G. Here weight is acting downwards. Suppose here a charged particle. Okay. So charged particle is placed here. Instead of Bob here, charged particle is placed. Then what about the time period? In this case, see, it is placed in what? Electric field which is acting downwards. Okay, simple pendulum what? Having a charge Q, mass M and effective length is what? L, is suspended from a rigid support. Okay, so electric field is what acting here? Means it is in electric field E which is acting downwards. So downwards means how can we write? Time period 2 pi root of L by G means G plus QE by M, right? Field also we have to add. How can we get net force now? Mg plus force due to electric field QE Mg dash equal to Mg plus QE. So take M common. So G dash equal to G plus QE by M. Suppose if field is acting upward, in that case time period is what? 2 pi root of here minus L by G minus QE by M. Okay. Next. Okay now. Now field is, see here downward, here upward. Suppose here field is acting horizontally, electric field. Electric field is what? Acting horizontally. In that case, so it is Bob now. So see here electric field is what? Applied along horizontal direction. See in this direction it is acting. Then so it can just pull now due to this horizontal electric field. So the pendulum what makes angle theta. So at this point what, say it is Mg. Here horizontal now. So in horizontal direction field is acting. So due to electric field what is the force? QE. But in this direction and in this direction. So it is theta now, it is also theta. So tension will resolve. T cos theta, T sin theta, right? T cos theta and T sin theta. Now we can write T sin theta equal to QE and T cos theta equal to Mg. Okay. Are you there, boys? Yeah. So here what is the net time period? Time period ఏమవుతుంది ఇక్కడ? See net tension. Square and add. What will you get? Square and add. What will you get here? T square sin square theta plus T square cos square theta. That is T square equal to Mg square plus QE square. And T equal to what? Mg only na? M into G dash whole square. Or take this side Mg dash Mg whole square plus QE by QE whole square. So G dash equal to what will you get here? M will come out and gets cancelled. Under root of G square plus QE by M whole square. This is G dash value. Now see, whatever the time period, T equal to 2 pi root of L by G, na? In that case, so T equal to what? So let it be T3, 2 pi root of, is anyone there? Are you able to follow this, guys? Reply here. Today someone not came, na? Any new members came here? Just once message here. I will tell you about evening classes. So time period is 2 pi root of L by, what is that? Root of G square plus QE by M whole square. This is the new time period. Okay. Suppose, see, in this case, if you see, this is positive charge plus Q, na? Suppose at the point of suspension one more charge is placed, then if one more charge is placed, then what will happen? Actually what? Same like charges, na? So net force becomes 0. So it will be balances. In that case, what? No electric force will act, because electric force will be what? Balances. So electrostatic force does not provide what? Any component to the restoring force. So time period what? Does not change, remains same. So 2 pi root of L by G only when we place a similar charge here. Okay, now? So that is the application of electric field. So very, very important applications these are. Okay, next. I will give you, see, 2 point charges 4 microcoulomb and 9 microcoulomb are separated by a distance 30 centimeter. 4 microcoulomb, 9 microcoulomb separated by 30 centimeter. Find the point where the strength of the field is 0. What we should find? Where the strength of the field is 0. Strength of the field is 0 means what? Null point. Null point distance, right? Same like electric force, only here we will get the null points. Electric force like in between like charges, in between force 0. So field is also 0. And one more is what? Along the line joining, means away from the line joining. Okay. So it will be. We'll see now. See Q1, Q2. Like charges. See, these are the like charges. See, due to this Q1, what is the field direction here? Away. Due to this, here, away. Suppose at a point P, see distance is D, at a point X, means at a distance X from point P, net field is 0. So net field is 0 means what? Field due to any point is same. See, field due to this charge Q1, what will get? K into 1 by 4 pi epsilon naught into Q1 by X square equal to K into what? Q2 by, what is the distance here due to this point? D minus X, na? So D minus X whole square. So K cancel. So D minus X by X whole square equal to Q2 by Q1. Right? So D by X minus 1 whole square equal to Q2 by Q1. So D by X minus 1 equal to what? It will come this side, na? It will be under root of. So D by X equal to root of Q2 by Q1 plus 1. So X equal to now D by under root of Q2 by Q1 plus 1. Suppose if these are unlike charges, one is positive, one is negative. In that case, for null points means net field 0 in or beyond the line joining. Sri Shaga. Hi, good evening. Sri Shaga. Good evening. Where are you from? Q1 minus Q2. So in that case, what? It forms near the small charge. See, at a point P here, net field will be 0. It is at X distance. And it is what? D na separation. So it will be D plus X. Now, here due to field even here in this direction. Now what is the net field? K into Q1 by X square equal to K into Q2 by, what is this? D plus X whole square. So D plus X by X whole square equal to Q2 by Q1. So D plus X by X equal to what? Under root of. It will D by X plus 1. So D by X equal to root of Q2 by Q1 minus 1. So X will be what? D by under root of Q2 by Q1 minus 1. Hi Shivani, good evening. Good evening Shivani. Just 2 minutes only remaining. So here net electric field, null point due to electric field is what? Same formula like null points due to electric force. What is that formula? What is the formula? X equal to D by root of Q2 by Q1 plus or minus 1. Plus is for like charges, minus is for unlike charges. So in this problem 4 and 9 like charges na. So like charges means you can take plus. You can take plus. So you will get the answer. This is Q1, this is Q2. Let's take here X. So what will you get? What is D here? 30 centimeter by root of 9 by 4 plus 1. That is 3, 9 by 4 means 3 by 2 plus 1. 5 by 2. So 60 by 5. 12. So X will be what? 12 centimeter. From what? This charge. So from 9 microcoulomb means 30 minus 12, 18 centimeter. So like this we can get it. Okay. So this is about null points due to electric field. So still more concepts are there. Okay. Still more concepts are there. We will see in day after tomorrow class because we have only half an hour session now. Okay. and everyone join in our special classes evening daily 6 to 7 p.m. and from that you can join in plus classes. So you can download Unacademy Learn app. See the description for getting details and use my code Kiran Live or in the classes Kiran MSc 08-5140. Yeah, Sri Shaja. I think you are a new member, right? You can download Unacademy Learn app and select TS and AP EAMCET and open my profile Paniharam Kiran. Follow. And while entering the video, you can use this code Kiran MSc 08. Kiran MSc 08-5140. Okay, na? Right. Bye, all of you. We'll meet in evening.